Hi everyone, welcome back to CS128 Honors. Today we're going to go through lecture 13, which is message passing with mpsc. So before we begin, today is the 14th of March, so it's Happy Pi Day to everyone. And here is a picture of a Rust logo on the Pi. So what we'll cover today, we'll talk about message passing and shared memory, and we'll explore how to use the mpsc library in Rust. So if you want to follow through by yourself, you can read the Rust book chapter 16.2, using message passing to transfer data between threads. So in the last lecture, we talked about multi-threading, and you guys learned about how to spawn multiple threads and use join to wait for the child threads to finish, right? So now we go into the next part of learning how to write multi-threaded code, which is communications, right? How the threads talk to each other. This could be as simple as like threads updating each other of their status, threads working on the same data together, but all this involves some form of communication. So there's two main ways in Rust where threads can communicate with each other. The first way is using shared data. So it's literally a piece of data. You can think of it as a variable that different threads have access to the same piece of variable, right? So when different threads access the same copy of the data, it is faster because there's only one copy and you don't have to copy it between multiple places. But it's also easier to create bugs due to synchronization. Imagine if one thread tries to update it while another thread is trying to read it, and this will cause other problems. So after spring break, we'll learn how to deal with shared data and doing it correctly in Rust. But today, we're going to talk about the other way to communicate between threads in Rust, right? And this other way is called message passing. So it's literally communicate by sending messages to each other. So a thread can send messages to another thread, right? So this is slower, but you have less problems with synchronization, and it's less likely to create like synchronization bugs. So how does message passing work in Rust? Rust implements channels, which is kind of a stream where data is sent from one thread to another, right? So you can imagine the channel as a river with a flow direction. If you put a rubber ducky into the water at this point, it will flow downstream and it will get picked up, right? So there's two halves to every channel. There's a transmitting half and there's a receiving half. Or some places in the documentation call it the sending and the receiving, right? So the sender will put the duck in and the receiver will pick up the duck on the other side, right? So here again, I said this is a typo, you can imagine the channel as a river, right? So here the transmitter will put a duck in, and then it will travel across and the message will get picked up by the receiver. Okay, this is like all pretty simple concepts so far. So let's look at how to actually program it in Rust, right? So in Rust, you use a standard in the Sing library. There's this thing called mpsc, and mpsc stands for multiple producer, single consumer. And the idea here is that I can have multiple senders of data, and only one thread can receive the data, right? So multiple threads can send data, and only one thread can receive. So in Rust, you can just call mpsc channel, and this creates a new data channel, right? And it gives you a tuple, it returns a tuple, and the first entry in the tuple is the transmitter or the sender, which we call tx, and the receiving end is called the receiver. It's called the receiver, which we call rx, right? So when we do let with the tuple like this, tx and rx will become the sender and the receiver. So how do you actually send something using the sender? So what happens is, for example, here, now that we have created this channel, we spawn a new thread, right? And this is all the same as last lecture. What happens here is that we write a new string called test, right? And what happens here is the most important part here is that you look at the sender, which is tx. We write tx.send test, and this is the message to be sent across, right? Which is this object, which is a string. So take note that the ownership of the tx, which is the sender, is moved into the thread because of the move keyword here. So once we use the transmitter here, the tx, we cannot use the tx out here anymore because it has been moved inside the thread. Now tx.send returns a result, right, like this, and let's talk more about it. So the result that's returned by the tx.send is of the OK type, which is nothing, like because you send the data and there's nothing. And if it's an error, it will be the of type send error, right? Error usually means that maybe the receiving side has already closed or is dropped, right? So it means that the channel is broken and the data will never be received. Whereas on the other hand, OK means that the message has been successfully sent out. But this does not mean that the data will be received by the receiver side, right? So the message has been sent out, but the receiver side can still close the channel before it has received the message, right? So there's no guarantee there that the data is sent to the receiver. Hold on, my slides are lagging again. Right, so let's look at how it's received on the other end, right? So again, here we create a channel, and here was the code just now where we spawn some threads, right? Now, how do you actually receive the data? What happens is that you use the Rx, which is the receiver end, and you call the function rx.receive, right? So the receiver end calls receive, and this part is where you should actually be really careful about programming it, because this receive function call will actually block the thread, right? So whichever thread calls receive will stop there and it will pause on that line of execution. And this will only wake up meaning that it will come back from being put to sleep if a message is received on the channel or if the sender side is disconnected. So here we see that the receive functions, it returns a result, and this result wraps, if it's OK, it will wrap the message that's being sent, or if it's not, it will return a receive error, right? So again, as I said, it will block the thread till something happens, where something is you receive a message or if the sender is disconnected. Error means that the sender side is disconnected, and OK, which means like the result turns out fine, will be the message that we are waiting for of type T. So if you put it all together, it's really quite simple, right? So we have the mpsc channel function, which creates a channel, giving us the sender and the receiver. Now we spawn some threads and we move the sender in to send some data. And in the main thread here, recall that this is part of the main thread. The main thread here will receive the data, right? So it kind of looks like this. If you remember this slide from the last lecture, we have the main thread, and now we spawn the new thread out here. And this new thread is responsible for sending a message, whereas in the main thread, we just wait for the message. So let's take a look at a demo. So here we just write the code that we have written in the slides. Let tx rx equals to mpsc channel. And then now we spawn the thread. In the thread, let's create a message to send. So let's create a message. We create a new string saying, I love CS128 honors, right? And then we do tx the send, and in that we send the message. So now the type of this channel is a channel that is sending strings, right? Because here we send a string, and that means the receiver end will also receive a string. So let's look at that. So the rx.receive, and this will receive a string, right? So recall that when we do receive, it gives us a result, and this is not very useful, and because we want to actually see the message. So what we can do is that we can unwrap the results. This is not a good idea, but just for demonstration purposes. And this will give us a string, right? So let's try to print out this string. So we can use the print line function, and then so now so overall, this is the channel is created. The sender will send a message inside the thread, and the main thread will wait for the message and try to print it out, right? So let's try to run this. Cargo run. So it builds, this is the build, and then we can see that it runs successfully, which is the main thread receives the message, I love CS128 honors. So let's make this make this a bit more interesting, and let's demonstrate how the message sending and receiving is done in real time, right? So now instead of sending just one string, let's send maybe a whole vector of numbers maybe. So we create a vector, and now we send the vector, right? So on the other hand, now the receiver will have to keep waiting for so okay, let's change the way that the message is being sent. So we write a for loop for number and message. This will look through all the numbers in the message. We do tx.send number, and then let's say we go to sleep, maybe for 1 second. So we go to sleep for 1 second, and then we don't need this line anymore. Okay, so now what happens here is that the thread that is spawned is trying to send one number and split up by like one number per second. So it sends one number, wait 1 second, sends one number and sleeps for another second. Right? Let's take a look at how the receiver will receive it. So the receiver has this nice function where you can use it in a for loop. So for example, you can do for message in Rx, and this will kind of just keeps calling, is the equivalent of continuously calling Rx or receive. And again here, this for loop, it will block when there is no message, and you'll get a message in like this message variable when a message is received on the channel, right? So do note that this message, unlike when we use Rx or receive, that returns a result, but message here directly returns us the message that is contained in within. So we can directly print out this message actually. So let's try it. So overall, the spawn thread will loop through the vector of numbers and send it every 1 second, and the receiver will just wait. Every time it receives a message, it will enter the loop and print it out. So let's try it. Look at how it's printing out 1, 2, 3, 4, 5, 6, and then it ends, right? Because why does it end? Because when the child thread is done, it exits the child thread, and that means the transmitter gets dropped, right? The sending end of the channel is now dropped, and that means the receiving end, this will detect that the channel is no longer valid, and it will exit the for loop, right? So this is neat. And then I just want to showcase one last thing, which is with regards to the ownership of the messages that's being sent, right? So now imagine that we didn't send the messages, the numbers in the vector one at a time, right? What if we wanted to send the whole vector, right? And remember that for objects like vector, there's an ownership, right? Because we don't copy them when we send them out. So what happens here is that actually the whole ownership of the vector object gets sent in the message, and the ownership will get transferred to the receiver, right? That means the sending side will lose ownership of the message it's trying to send, and the receiver side will get the message. So we don't actually care about seeing the receiver here, but I just want to demo that the ownership gets dropped, right? So here, if we try to print line, remember that we can print a vector, and let's try to print out the vector after sending it, right? So we know that this is invalid because like especially my novim here actually already shows you. So the value is moved here in this when you send it out, and you're using the borrow of the move value. But let's just try to run it to see what the compiler says. So let's do cargo run, and you look, it gives an error, borrow of moved value message, right? So the move occurs because message does not have copy, and is moved in this message, is moved in this line when we send the message, and we're trying to use it after the move. And this is again something you should be familiar with by now, where you're trying to use something after the ownership is transferred, right? So this is the end of the demo, right? So what should we take note of? The first thing we need to remember is that the ownership of the message gets transferred from the sender to the receiver. So on the sender side, after you send the object out, you cannot use it anymore. Now, let's go back to the term mpsc. mpsc means multiple producers, single consumer, right? So actually, this allows us to actually create multiple senders, right? And all these multiple senders will send to one single consumer. So this is what I want to demonstrate here with multiple senders. Let's say now we have 3 senders, and it's all the same receiver receiving all the messages, right? So the first sender will send, and the second sender will send, and the third sender will send. I mean, of course, the messages won't come in any particular order, but this is how you actually send out the message. So let's look at the code of how you send out multiple senders. So again, we create a channel here. But here, instead of spawning just one thread, let's spawn 5 threads instead. So I put it in a for loop. So before we spawn the thread, how you actually create multiple senders is to actually clone the sender side. So we can do tx.clone here, tx.clone, and here when we move, here we're actually using the clone of the sender to send a message. So now we're actually creating 5 different sender sites, right? And so the message here that we're trying to send is a string, which is a hello from thread, and then just the number I converted to a string. So you will say hello from thread 0, hello from thread 1, etc. And in the receiving end, it's just, again, we'll just keep waiting for all the messages and we'll see it come in, right? So let's take a look at how it works. So here, I will create the threads in a for loop. So for I in 0, 5, let's clone the transmitter. And then we just spawn the thread. Well, again, we move the transmitter in, and then we spawn the thread. We create a string, or we don't even have to create a string. We can just use the number, right? So we can just do tx clone dot send, and then we can send the letter I, and this will send the number across. And then now on the receiving end, we can just do we just receive in a loop, right? So for message in Rx, we just print out the message. Okay, so let's try it. So see, what happens here is that we created the 5 threads, and they all try to send their number, right? So 0, 1, 2, 3, 4 all try to send a number, and the receiving side will receive the message one at a time. And we see that it doesn't come out in order. It comes out 1, 0, 2, 3, 4, which it goes back to what we said earlier, because whenever we do multi-threading and we create multiple threads, there is no guarantee that we can do for how the threads are being scheduled, right? So in this case, thread 1 managed to send a message first, followed by 0, followed by thread 2, 3, and 4. So that's how multiple senders and a single receiver works. Okay, so that was the end of the lecture. MP3 is released today on Prairie Learn. It's due 3 weeks from now. So we're giving, usually MP is 2 weeks, but next week is spring break. So it's due 3 weeks from now. Remember to form the project groups is due today on 14th of March. And the link to form the project group is in the Discord or in the email I sent out. So have a good spring break, everyone. And MP3 is the last homework. So this is also the last kind of homework that we have in the class that is graded. So yeah, happy spring break.